Next, normal distribution. We're just looking for the values here. The mean 177, standard deviation 7.5, and this question has a bit of conversion involved. 6 foot. Okay, we need to multiply 12 inches by 6 to get 72 inches, and we need to multiply the inches by centimeters to get the height of this 6 foot male. That's going to give 182.88. I won't round off too early in this question because it does give a different answer in this case. So we're testing 182.88 against an average of 177, and we're dividing by standard deviation of 7.5. So that's a z-score of 0.784. And 0.784 gives a z-score value of 0.7823. 0.7823, they're very close together. Coincidentally, these two, but they're not linked necessarily. So we have 78.23%, so we're left with 21.77% left in the sketch that we drew before we started the question, just to let ourselves see where we're at. We're testing against 177, up here 180. I'll round it off just for here, so we're looking in there. So 21.77% every day. Max temperature, mean temperature 0.6, standard deviation of 8. Assuming the max temperatures are normally distributed, the probability that the max temperature or the temperature will reach 25 or higher on a random day. So we're testing 25 against an average of 9.6 with a standard deviation of 8, which is going to give me a z-score of 15.4 over 8, which is equal to 1.925, which gives me a value of 0.9729. So what part of my normal distribution curve am I looking at? Got my average in the middle, 9.6. I'm testing 25 up here, and will reach, so we're looking for this point here itself. So it's 1 minus that. The chance of that happening is 0.0271. So a 2.71% chance, or 0.0271 for the first part. On how many days? So we're looking at multiplying something by 365 here, and this is the previous. Yeah, it's the previous. So 365 by 0.0271 gives me 9.89. I think we get away with rounding that to the near. Oh, that's the nearest whole number. So 10 if we round. And a weatherman says that he would expect the temperature at Athlone to break 30. That's a seriously hot day in Ireland on 2 days in the year. Is this a reasonably accurate statement? Well, let's test 30 against 9.6. 30 minus 9.6 over 8 is going to be 20.4 divided by 8, which is a z-score of 2.55. So that's tiny. So we're a tiny little tail at this end here. 2.55. 2.55 gives a z-score of 9946. So my z is 0.9946. So there's 0.0054. If we multiply that by 365, we are going to get how many days we're going to get? 1.971. Yeah, there's a reasonable chance of it happening. Yeah, I'd say that's a reasonably accurate statement. It could happen. Okay, the lifespan of a bulb is normally distributed with a mean of 1020, standard deviation if 12%. So find the standard deviation. First time we've looked at one of them. If 12% of the light bulb, so they're telling us something there, that's 0.12, so we're possibly looking at a 0.88 in this question. If 12% have a lifespan of 1067 or more. So let's do a little sketch. we have a mean of 1020. We are looking for standard deviation, so we don't know it yet, but what do we know about our tail? What's in here? 1067. 12% have a lifespan of more than 1067, so this is 0.12. So we need to look up what z-score gives us 0.88. As we said, we were going to be using that in the question. So what z-score gives a value of 88%, 0.88. Is it 0.88? There's a 0.881 and it's 1.18. 1.18. It's the exact midpoint of 1.18 and 1.17. So I'm going to take 1.07 and 0.8, 1.075. It's the exact midpoint. So our test statistic 1067 minus 1020 divided by my standard deviation. I'll just call it, I'll call it x. It doesn't matter what we call it. I can call it sigma if you want. Maybe keep it like that. Is equal to this 1.075. So to solve for sigma, just seeing if that's 1.175. I think I said 1 and wrote 0. It's 1.175. So we're gonna have 47 over sigma is equal to that 1.175. So sigma is equal to, they swap places, 47 divided by 1.175. And 47 divided by 1.175 is 40. Standard deviation in this case is 40. So they can ask any of the unknowns, which they have in number 12. Number 13, time in minutes this time, maths test. Mean 60, standard deviation of sigma. 34% took between two values, 51.2 and 68.8. 51.2 and 68.8. So let's have a look here. We're looking between two values this time, and we're looking for sigma again. So between 51.2 and 68.8, 34% is in there. That's what we're told. That looks like it could be empirical rule. 34% is in there, and the mean is 60. And this is 34%. So that means that each tail, if that leaves 66% overall, in each tail there's 33%. So I can definitely get this number here. Is there a relationship? Is there we're going up 8.8 and we're going down 8.8 as well, you can see. And the empirical rule, with that 34% being in the middle, you should identify as well. But I think the easiest way, if there's 33% in the tail, we need to look up, that's going to be 0.67 to leave 33 on the other side. So 33% in here. So if we look up a z-score of 0.67, we're going to get 0.44. So if I test 68.8 against 60 and divide by my standard deviation, I'm going to get 0.44. So my 8.8 divided by my 0.44 will be my sigma in this case. So sigma, or standard deviation, is equal to 20. And then finally in this video, the heights of male Gardaí have a normal distribution with a mean of 173, standard deviation 2. The tallest 2.5% of male Gardaí have heights of greater than x. Find the value of x. So how tall are these greatest height of these Gardaí at the top end of the scale? 173 is the mean. And we're looking for 2.5% in the tail. 173 and 2.5% in the tail. So we have a mean of 173. There's 2.5% in this tail drawn badly. Just round it off. That's 2.5%. And standard deviation is 2 centimeters. So what are we asked in this case? find the value of x, the tallest, the height's greater than x, so we're looking for the height represented by this point here. What height is represented by here? So we need 0.975, 97.5% to leave 2.5% in that tail. And that's represented by exactly, you guys know, 1.96. 1.96. So we're looking for the test statistic this time. X minus mu, 173, over standard deviation is equal to 1.96. More accurate than your empirical rule. So x is equal to twice 1.96 plus 173. So it's not the exactly 4 centimeters. It's going to be 173 plus 3.92, which is 176.92 centimeters for the height of the top 2.5% of Gardaí.